systems? Anybody know? Charlie?
Like the highest degree is one.
Yeah, the highest degree is one, exactly. There's some vocab that goes with this. Start. I can start writing. Doesn't want me to. Okay, there we go. So let's talk about what an independent system is. So an independent system is when a system of equations has exactly one solution. And we know a linear equation is a line. So when we have a system of linear equations having exactly one solution, that means that the two lines cross at exactly one spot. And that point is always the solution. So where those two lines cross, that is our solution. So an independent system has exactly one solution. Okay, so now let's talk about a dependent system. So a dependent system is when a system of linear equations has all solutions in common. So an independent system is when those two lines cross in just one spot. What do you think it looks like when a system of linear equations has all solutions in common? Vivek? Yeah, one line is completely on top of the other line. So if this is my first line, my second line is completely on top of it. Every single point matches up. So we spoke about when a system has just one solution in common. We talked about when a system has all solutions in common. Is there a way to have just two solutions in common? Is there a way for a system of linear equations to have two solutions? There's no way. There's no way for two different lines to cross at only two spots. It's either one spot, all spots, or what? No spots, right? We can only cross at one spot. Every point be the same or nothing at all, meaning we're not crossing at all. So that brings us to some more vocabulary words. Let's talk about a consistent system. So a consistent system is when a system has at least one solution. When a system has at least one solution, what does that mean, at least one solution? One solution or more, right? Isn't at least one that number or more? But remember, we just spoke about it. There's no way to have two or three or four solutions. It's either one solution or all solutions. So this would look like one solution or all solutions. So that's a consistent system. And now that brings us to an inconsistent system. And an inconsistent system is a system of linear equations which has no solution. What does that look like if my system of linear equations have no solution? Lily? Parallel lines, you got it. Does anybody remember from geometry how to mark parallel lines? The tick mark for that shows that the lines are parallel. Charlie?
Like the little arrow.
Yep, it's an arrowhead going in the same direction. You got it. That shows parallel lines. Okay, so now what I want us to do is I want us to solve the system by graphing. So the first one is going to be 2x minus y equals 5 and negative x plus y equals negative 3. If you guys want, I'll pass around graph paper. We're only going to do 3 graphic problems, but if you want, you could take a piece of graph paper and pass it around, or just skip it, just keep passing it. All right, now in order to graph this, who remembers from Algebra 1, what format do we need to put this in for me to be able to graph this? You got it. We want it in slope-intercept form. We want it to look like y equals mx plus b. So in order to make this look like y equals mx plus b, I need to isolate the y. So what I'm going to do is I'm going to first subtract 2x on both sides. So now I'm going to have a negative y is equal to negative 2x plus 5. I'm still not done. There's still that negative 1 with the y, so I'm going to divide every single term by negative 1. So I end up with y is equal to a positive 2x minus 5. And when it comes to graphing and we put it in slope-intercept form, we make it look like y equals mx plus b. There's 2 important parts here. Our m, which is our slope, and I always write that as a fraction, so that's 2 over 1. And my b, which is the y-intercept, that's negative 5. Now let's put the other equation in slope-intercept form. So once again, I'm going to isolate the y. So I'm going to add the x over on both sides. So this is going to be y is equal to x minus 3. And so there's 2 things we need to know. Our m, which is the coefficient of the x. And if there's nothing there in front of the x, what number is that? 1. So this is 1 over 1. And our b, which is negative 3. And now we go and we graph. Okay, so to graph the first line, you start off with your y-intercept. Your y-intercept is -5. To keep going here. Oh, that's not good. Try this again. All right, and so we're starting off at -5, so we're down 5 on the y. 1, 2, 3, 4, 5. That's my y-intercept. And from there, we're going to move according to the slope. So our slope is 2/1. This is our rise over our run. So we're going to rise +2, so that's up 2, and we're going to run +1, so to the right 1. So we're up 2 to the right 1, up 2 to the right 1. I'll make a couple more dots, up 2 to the right 1. And in the other direction, we're going down 2, left 1, down 2, left 1. And then we connect it with a line. Why do I have to put arrows at the end of my line? Charlie? Yep, because the line doesn't end where we stopped our dots. Our line goes on forever. All right, now we need to graph the other line. So the other line, my y-intercept is -3, so I'm going down 3 on the y-axis. And now my slope, which is my rise over my run, is going to be up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, and then down 1, left 1, down 1, left 1. And then we connect. Oh, I left messed up. And then we connect with a line. And now our solution is where the two lines cross. That's this point right over here. So we look to read that point. That's going to be, remember, our point is always x comma y. So our point, our coordinate on the x-axis is a +2. My coordinate on the y-axis is a -1. So our solution is the point 2, -1. And that's where these two lines intersect. So now I'm going to ask you, first question, is this a consistent system or an inconsistent system? Violet? This is consistent. Remember, consistent means one or more solutions. And then since it's a consistent system, now we have to ask ourselves, is it independent or dependent? Independent. So this is consistent and independent. Okay, guys, I want you guys to try. Actually, we'll do this next one together still. So we're going to have same thing. We're going to find the solution by graphing. So we have 5x minus 3 times the quantity of y plus x equals -6. And then 2x minus 3y equals 3. So in order to graph these, what must we do? In order to graph them, what should we do? Put the equations in? You got it. We want to put them in slope-intercept form. In order to do that, I need to isolate the y. On the left side here, on this left side equation, there's a lot going on. I need to first get rid of these parentheses. In order to get rid of those parentheses, I need to distribute. But when I'm distributing, I'm not distributing a +3. What am I distributing? A -3. So we end up with 5x minus 3y minus 3x equals -6. Now I'm going to combine my like terms. So I have a 5x and a -3x. That gives me a +2x minus 3y equals -6. I need to isolate the y. So I'm now going to subtract the 2x on both sides. So I have negative 3y is equal to negative 2x minus 6. My last step is to divide everything by negative 3. So we end up with y is equal to a positive 2/3 x plus 2. Okay, you're welcome. Bye. Any, Mr. Flacker needs to see you. Okay, so here there's two important numbers we need to graph this. Our m, which is our slope, that's a positive 2/3, and our b, which is our y-intercept, is a positive 2. Now let's go ahead and put the other equation in slope-intercept form. So once again, we need to isolate this y. So I'm going to subtract 2x on both sides. So we have a negative 3y is equal to negative 2/3, negative 2x plus 3. Now we divide by negative 3. So we end up with y is equal to a positive 2/3 x minus 1. So here our m is 2/3 and our b, our y-intercept, is negative 1. What do you realize here with these two equations? They have the same slope. Do they have the same y-intercept? No, since their y-intercept is different, can these be the same lines? Could it be like one line on top of the other line? There's no way. If it was one line on top of the other line, they'd have the same slope. And what else would they have the same as? The y-intercept. So these lines are not on top of each other. Who remembers? You talked about this in Algebra 1. You talked about this in geometry. What does it mean when the slopes are the same, but the y-intercepts are different? They're parallel. These two lines are parallel. Let's go ahead. And if these two lines are parallel, what does that mean in terms of solutions? It is inconsistent and there is no solution. So here right away, we know this is a no solution. And this is going to be an inconsistent system. And just to prove that, I'm going to graph this. So our first y-intercept is a positive 2. And then we're going up 2 to the right 3. And then down 2, left 3. And our other line, we have our y-intercept, I think is negative 1, was it? Yep. Our y-intercept was negative 1. And then we're going up 2 to the right 3. And then down 2, left 3. Something went wrong here. 1, 2, 1, 2. Yep. One of my points was wrong. That's why my line looks weird. All right, let's try this again. There we go. That looks a lot better, I think. All right, and as we can see, these lines are parallel. Okay, next one. So for this next problem, what I want us to do, I want us to find K if Kx minus 3y equals 9 and 2x plus 3y equals 12 is a consistent system. And if this is a consistent system, what does that mean? What are our options? If it's a consistent system, what are our options for solutions?
That's one intersection of the everywhere.
Good. So it's either there's one intersection or they end up being the same line where they overlap each other and it's all solutions the same. So what I'm going to do is I'm going to put each of these into slope intercept form. So I have 2x plus 3y equals 12. I'm going to subtract that 2x on both sides. So now we have 3y equals negative 2x plus 12. Divide by 3 under everything. So we get y equals negative 2/3 x plus 4. So that was one equation. Now I'm going to put the other equation also in slope-intercept form. So I'm subtracting the kx on both sides. So I have negative 3y is equal to a negative kx plus 9. And now divide everything by a negative 3. And so now we end up with y is equal to a negative divided by a negative is a positive. So this is k over 3x minus 3. These are the two equations of our lines. And now we want this to be a consistent system. In order to be a consistent system, they either need one solution or all solutions. Is there any way it's ever going, sorry, that should be a y equals. Is there any way this is ever going to be in all solutions where they're the same exact line? There's no way it's going to be the same exact line because their y-intercepts are. So that brings us to just wanting to have one solution. Well, if the slopes are the same, will they have one solution? No. If the slopes are the same, they'll have no solution since the y-intercepts are different. So we need to just make sure that these slopes are what? Different. As long as the slopes are different, won't these lines at some point intersect? All right, so what do we need? We need negative 2 over 3 to not equal k over 3. I think this is pretty self-explanatory. What can k not equal? Good. K cannot equal negative 2. But what you can do is just cross multiply and get negative 6 equals 3k. If it wasn't so self-explanatory, divide by 3, and we can make sure that k does not equal negative 2. And that's your answer, yes. Okay, so now let's talk about solving systems algebraically. There's two methods when we're solving algebraically. There's one that we could use we call substitution. The other one is elimination. You did this in Algebra 1. You did it again in geometry. We're pulling it back in for Algebra 2. So let's look at the substitution method first. So let's say I have x plus 2y equals 6. And the other equation is 4x minus 3y equals -9. When we're solving a system using substitution, what you want to do is you want to look at the two equations that you're given. And we want to manipulate one of the equations to get one of the variables by itself, either x equals or y equals. And the way you choose between the two equations is you try to see which variable in either equation, if possible, does not have a leading coefficient or a leading coefficient that's not 1. You guys see how the x doesn't have a leading coefficient, but in everything else there is a leading coefficient? This is going to be the easiest one to manipulate. Meaning I'm going to get x by itself. And the reason this is going to be the easiest one to manipulate to get x by itself is because I won't have to divide anything, which means I'm not subbing in any fractions. And that's why it's easier. So I'm going to solve for x. So I keep x by itself. I'm going to rewrite this. And to get x by itself, I'm going to subtract the 2y on both sides. So now I have x is equal to -2y plus 6. Now what you want to do, once you've solved for one of the variables, you want to take that x equals -2y plus 6, and you're going to go to the other equation. And you're going to now, anytime you see an x, you're now going to sub in -2y plus 6 for that x. So now we're going to have 4 times the quantity of -2y plus 6 minus 3y equals -9. And you're now going to solve for y. So to solve for y, I need to distribute in that 4. So I have a -8y plus 24 minus 3y equals -9. We're going to combine our like terms. So we have -11y plus 24 equals -9. Subtract that 24. So -11y equals -33. So y is equal to 3. Now that you found the y, we need to find the x. You go back to one of the equations. It does not matter which equation you plug back into. Doesn't matter. I'm going to go back to the original, x plus 2y equals 6. Or I'd go into x equals -2y plus 6. And now I'm going to sub in that 3. So x plus 2 times 3 equals 6. So x plus 6 equals 6. We're going to subtract that 6. So x is equal to 0. Is it okay that x equals 0? Absolutely. So what is our solution? These two lines are going to cross at the point 0, 3. Is this a consistent or inconsistent system? Consistent or inconsistent? Consistent. Independent or dependent? Independent. So that was solving through substitution. The other way we solve is through elimination. So let's talk about solving through elimination. So guys, this is just a refresher because I know you did this in Algebra 1. I know you did it. We did it again in geometry. Briefly in geometry. Okay, so now we're going to solve through elimination. Let's say I have 2x minus 4y. Actually, sorry. Let's have 5x minus 2y equals 20. And 7x equals -4y plus 1. Okay, so now if we're solving through elimination, you want them both to be in the same format. What you want is for the x's and y's to be on one side of the equal sign and anything that doesn't have a variable on the other side. So our first equation, 5x minus 2y equals 20, is in the perfect format. Our second equation is not. We have 7x on one side, negative 4y on the other side. So I'm going to move that 4y over. So now we have 7x plus 4y equals 1. And then what you do is you line the two equations up. 5x minus 2y equals 20. And then we have 7x plus 4y equals 1. Oh, sorry, that should be an 11, not a 1. Make this an 11. And now you ask yourself, once you've lined them up, the x's have to line up together, the y's have to line up together. You ask yourself, if I were to add these two equations, would anything cancel? As of right now, no variable would cancel if I added these two equations together. So now what we want to do is we want to make one of the variables cancel. And you make it cancel through multiplication. So we have the choice. Do we make the x's cancel or we make the y's cancel? Sometimes there's no easier variable to make cancel. In this scenario, there is. Why is the y easier to make cancel than the x? Yeah, because 2 is a factor of 4, or 4 is a multiple of 2. Where 5 and 7, we'd have to change them both to 35. Where in this one, I could just change the 2 into a 4. And I already have it being negative. So I just need to multiply the whole top equation by a positive 2. So we're now going to multiply this whole top equation by a positive 2. And we are going to get 10y, 10x, not 10y. 10x minus 4y equals 40. Don't forget to multiply that 20 by 2 also. And in the bottom equation, we stay with the 7x plus 4y equals 11. And now we add. And when we add, we should definitely get one of the variables to cancel. 10x plus 7x is a 17x. A negative 4y and a positive 4y cancels. 40 plus 11 is 51. We divide by 17 on both sides. It does go in evenly. We end up with x is equal to 3. And now to find the corresponding y, we just take any equation and plug in for the x. So I'm going to take the 5x minus 2y equals 20. And I'm going to have 5 times 3 minus 2y equals 20. 15 minus 2y equals 20. Negative 2y equals positive 5. So y will equal a negative 5 halves. So our solution, where these two lines cross, is going to be the point 3 comma negative 5 halves. So now tell me, is this a consistent or inconsistent system? Yep, consistent. Independent or dependent? Independent. Okay, you guys try this one on your own, and you can solve it any way you like. How many people are choosing to solve this through elimination? How many people chose substitution? Okay, I would think elimination is a little bit easier. I would think elimination is a little bit easier. So if we're solving this through elimination, there's no multiple of the other one, meaning 3 is not a multiple of 2, 6 is not a multiple of 4. So if we're solving through elimination, don't I have to multiply both equations by something? I'm going to opt to cancel out the x's. If I'm opting to cancel out the x's, I'm multiplying the whole top equation. I'll do a -3 and the whole bottom equation by a +2. And when we get that, I'm going to get a -6x plus 12y equals -9. And in the bottom equation, I have a +6x, a -12y, and a +16. And then when we go to add, the x's cancels, the y's cancels. When everything cancels, what number is left? Everything cancels. What number is left? 0, right? There's nothing there. Equals a +7. Is there any variable to solve for? No. Does 0 equal 7? No. This is a no solution. What does that mean if it's a no solution? The lines are parallel. Okay, we are going to stop